Detecting honeypots running on VMware. Attackers can identify instances that are running on VMware virtual machine by analyzing the MAC address. By looking at the IEEE standards for the current range of MAC addresses assigned to VMware INC, an attacker can identify the presence of VMware-based honeypots. A MAC address for vCenter is assigned from the range. Uh, this is the range. A MAC address for vCenter is assigned from the range. This range. Detecting the presence of honeyed honeypot. Honeyed, Honeyd, is widely used honeypot daemon. It is used to create thousands of honeypots easily. It is network simulated and service simulated honeypot deployment engine. This honeyed honeypot can respond to a remote attacker who tries to contact the SMTP service with fake responses. An attacker can identify the presence of honeyed honeypot by performing time-based TCP fingerprinting methods, SYN proxy behavior. The following figure shows the difference between a response to a normal computer and the response to a honeyed honeypot to a manual sync request sent by the attacker. As you can see, a normal computer, when an attacker sends a SYN request, will respond with the SYNAC, and if there is no ACK packet from the attacker, then the normal computer will send SYNAC again after some period. Whereas this honeypot will send SYNAC once, but after that it will not send any other message. So this is one of the example of detecting the honeyed honeypot. Detecting presence of user mode Linux honeypot, UML honeypot, user mode Linux, popularly called as UML honeypot. User mode Linux is an open source software under GNU which is used to create virtual machines and is efficient in deploying honeypots. Attackers can identify the presence of UML honeypots by analyzing files such as slash proc slash mounts slash proc slash interrupts and slash proc slash command line, which contain UML specific information. Detecting the presence of SEBEC based honeypots. SEBEC is a server client based honeypot application that captures the rootkits and other malicious malware that hijacks the read system call. Such honeypots record all the data accessed via reading call. Attackers can detect the existence of SEBEC-based honeypots by analyzing the congestion in the network layer, as SEBEC data communication is usually unencrypted. Since SEBEC logs everything that is accessed via reading call before transferring to the network, it causes the congestion effect. Detecting the presence of Snort inline honeypot. Snort inline is a modified version of Snort IDS that is capable of packet manipulation. It can rewrite rules in the IP tables and is mainly used in Gen 2 second generation honeypots to block known attacks and avoid attacker bouncing. Attackers can identify these honeypots by analyzing the outgoing packets. If an outgoing packet is dropped, it might look like a black hole to an attacker, and when the snort inline modifies an outgoing packet, the attacker can capture the modified packet through another host system and identify the packet modification. Detecting the presence of fake AP. Okay, fake AP is access point. Note, an access point is a device that creates a wireless local alien area network, or WLAN, usually in an office or a large building. An access point connects to a wired router, switch, or hub via Ethernet cable and projects a Wi-Fi signal to a designated area. Fake access points are those that create fake 802.11b beacon frames with randomly generated ESSID and BSSID assignments. Fake access point only send beacon frames but do not produce any fake traffic on the access points, and an attacker can monitor the network traffic and quickly note the presence of fake AP. Detecting the presence of bait and switch honeypots. Bait and switch honeypots actively participate in security mechanisms that are employed to respond quickly to incoming threats and malicious attempts. They redirect all malicious network traffic to a honeypot after any intrusion attempt is detected. An attacker can identify the presence of such honeypots by looking at a specific TCP/IP parameters such as round trip time, the time to leave, and TCP timestamp. Honeypot detection tools. Send safe honeypot hunter. Checklists of HTTPS, SOCKS 4 and SOCKS 5 proxies with any ports. Check several remotes or local proxy lists at once. Can upload valid proxies and all except honeypot files to FTP. Can process proxy list automatically every specified time interval. May be used for usual proxy list validating as well. IDS firewall evasion countermeasures. How to defend against IDS evasion. Shut down switch ports associated with known attack hosts. Perform an in-depth analysis of ambiguous network traffic for all possible threats. Use TCP fin or reset packet to terminate malicious TCP sessions. Look for no-op code other than 0x90 to defend against the polymorphic shellcode problem. Train users to identify attack patterns and regularly update, patch all the systems and network devices. Deploy IDS after a thorough analysis of network topology, nature of network traffic, and number of hosts to monitor. Use a traffic normalizer to remove potential ambiguity from the packet stream before it reaches the IDS. Ensure that the IDS normalize fragmented packets and allows those packets to be reassembled in the proper order. Define DNS server for client resolver in routers or similar network devices. Harden the security of all communication devices such as modems, routers, etc. If possible, block ICMP TTL expired packets at the external interface level and change the TTL field to a considerable value, ensuring that the end host always receives the packets. Regularly update the antivirus signature database. Use a traffic normalization solution at the IDS to protect the system from evasions. Store the attack information. Example, attacker IP, victim IP timestamp for future analysis. How to defend against firewall evasion. The firewall should be configured such that the IP address of an intruder should be filtered out. Set the firewall rule. Set the firewall rule set to deny all traffic and enable only the services required. If possible, create a unique user ID to run the firewall services instead of running the services using the administrator or root ID. Configure a remote syslog server and adopt strict measures to protect it from malicious users. Monitor firewall logs at regular intervals and investigate all suspicious log entries found. By default, disable all FTP connections to or from the network. Catalog and review all inbound and outbound traffic allowed through the firewall. Run regular risk queries to identify vulnerable firewall rules. Monitor user access to firewalls and control who can modify the firewall configuration. Specify the source and destination IP addresses as well as the ports. Notify the security policy administrator about the firewall changes and document them. Control physical access to the firewall. Take regular backups of the firewall rule set and configuration files. Schedule regular firewall security audits.